Hello students, today we will be going over the second section of H1.4. We're going to learn to subtract vectors on the coordinate plane. Okay, go to page H15 in the pink packet and we are going to learn how to do subtracting vectors. So the first thing we want to do is there's two different ways to do it, just like there is on addition. If our initial point of U and V are at different places, we are going to be using the tip to tell example. Okay, so at the top of the page, if you have V here and you have U here, here's the initial point of U, here's the initial point of V. So they start at different points, so we can use the tip to tell. It just means, okay, after I get U, I'm going to make a negative U, which is opposite direction, the same length of U. And then I can use my addition rules. So again, here's U, I flip it around, and there's negative U. So to find U, or V minus U, we're going to change it to V plus negative U. So U, here's negative U, and here's V. So when I combine these two, I put the tail over here at the tip here, and I go this direction with the negative U. So my final answer is going to be V minus U will be this right there. And that's V minus U or V plus a negative U. It's the same thing. So our steps over here on the right is move what is being subtracted to the opposite direction. So in other words, find the negative of the second vector. 2, start with initial point of the first vector right here. Draw a vector from that point to the terminal point of the second vector that is being subtracted. So I go from here to the terminal point, and there you have V plus negative U. Okay. Now, you can only use this method when both the vectors that you're subtracting do not have the same initial point. Again, they're not starting at the same place. Okay, so V starts here, U starts there, so we can use this method. Next, the method is also used in your packet on that same page. It looks a little bit messy here, but if you see, U is here and V is here. Okay, so this time it's U minus V, whereas our other one was V minus U. So we need to make a negative V, which they do this direction, and then I go from the original point right here of U to the terminal point of negative V. So right there is my V minus U. And there you have it. Okay. So you get -1, 13 because we are going to be counting which right or left from the original spot. U was 5, 4. So U is 5, 4 right up here. And V was 6, -9. V started here, but it went over 6 and down 9. If you'll notice, this as a point does not match up with the coordinates on the graph because it did not start at the origin. So if it starts somewhere else other than the origin, this vector number is not going to match up because our vector for V is 6, -9, but this looks like it's 11, -5, and again, they won't match up if they don't start at the origin. Okay. So there's the rest of that example, and it also shows how to find the magnitude of the length of the vector, or the magnitude, which is the length of the vector. Okay, now we'll go on to the next example and the next method. Okay. Method 2 is when the vectors have the same initial point. When they do that, we have to use the parallelogram rule, which we learned a little bit about that for addition of vectors. In the upper right, you'll see that U and V have the same initial point, which is the origin. So now they want us to find u minus v. So we graph the second vector and as a negative. So if you have right here, v is over here. So negative v will be going the opposite direction, the same length. And then you graph the second vector from the terminal point of the first vector. See how we have the terminal point here? And we're going to graph, the first one is from the terminal point here. And we're also going to graph it right here as well. So it's going out that direction. Then from the original vector over here, we're going to draw negative v going that direction. And where those 2 points meet, that is where you draw your resultant vector, which is the vector v minus u. Or is it u minus v? Sorry, I think I said it wrong. Okay, so up here it says u minus v, but over here it says v minus u. So we better make sure that's correct. So if it's u minus v, yes, I think it's still u minus v, even though this part is wrong, says v minus u. So it's u minus v. Okay. So, and also down here it tells you u minus v. Since they're both from this origin, standard position, you could go ahead and actually subtract 3 minus negative 4, get you 7, and 5 minus 3 get you 2. So that vector is going to be 7, 2, and it will still be from the origin. And to find the magnitude, again, we take this first vector number, the x value, 7 squared, plus 2 squared equals c squared. So 49 plus 4 is 53, and then you take the square root of each side, and that's how you get that. Okay? Now we'll go ahead and, I'm not sure, go ahead and pause the video if you want to write down these steps. Sometimes step by step makes it easier. Same initial point, you want to use the parallelogram rule, graph the second vector as a negative, so that just means the opposite direction. Graph the second vector from terminal point of first vector, draw the first vector from terminal point of negative second vector, draw the resultant vector from initial point to across your parallelogram. So you'll notice here, the resultant vector is across the parallelogram, diagonal from there. Okay? So it might help to do an example, but I wanted to make sure you had those steps. And again, if I need to, I will pause the video. Next, we're going to go on to page H16 and do number 7. So if we look at H16, number 7, find H minus V. And what I like to do is write out what, actually it says U minus V. Okay, so let's find out what U is and what V is. So U right here does not start at the origin. So we got to count how many left. So that's going to be a negative number. And I should be doing this in a different color. And then how many up. So the first number is negative, but the second number is positive. So if we look at number 7, right here, that's going to be U. So I go how many over from 3 all the way to negative 4. So that should be 1, 2, 3, 4, 5, 6, 7 over. So that is going to be negative 7. And then how many up? We're going to count how many up from negative 4, and it goes all the way up to positive 3. 1, 2, 3, 4, 5, 6, 7. And I believe that's 7 as well. Okay, now we say V. What is V? V looks like it goes up. Actually, we have to go right first. 1, 2, 3. And up 1. Okay. All right, so we ask ourselves, is the initial point the same? No, U starts here and V starts right here, so we can use the tip to tail. So that just means we can go from the beginning of U to the end of V, and that would be U. Oh, whoops, we forgot something. My bad. We have to get our negative U, or negative V. Okay, so our negative V, instead of going up and this way, we're going to go this way. So negative vector V. Okay, so we have to go left 3 and down 1. So that should be at negative 6, 2. So that end point right there is negative 6, 2. And I don't know if we need to know that, but now we know our resultant vector should go from our original point of U all the way to our terminal point of negative V. So right here is going to be my U minus V. Okay. Now we can either use the component forms to find that, or we can just say, oh, okay, how many over and how many up. Okay. So negative 7 minus 3 will give you negative 10. And then 7 minus 1 will give you 6. So this point is actually going to be at negative 10 across and 6 up. And mine is not drawn to scale, so that's why it doesn't look kind of like that. Then we have to find the magnitude of this. So we say we're going to take, this is going to be our c squared, and that is going to be equal to our negative 10 squared plus 6 squared. And then we say c squared equals 100 plus 36. Then you take the square root of each side. So c equals, we take the square root of 136. Go ahead and do the factor tree first. We can see that 4 goes into that times 136. And remember your factoring rules where if 4 goes into the last 2 digits, 4 will go into the whole thing. And I know 4 times 9 is 36, so I know 4 goes into this whole thing. And that ends up being 34. So 4 comes out. Again, it's a perfect square. So I could say it could be 2 square roots of, and this is 17 times 2. Remember, when they have pairs, one comes out, one goes away. So it's 2 square roots of, and then I just multiply 17 times 2 together to get 34. So that's 2 square roots of 34. And then c is also approximately equal to 10.05. Okay. All right. All right, we're going to go ahead and go on to the next one. Let's go on to number 8, which is u minus v. The first thing we ask ourselves, does it have the same initial point? And since they both start at the origin, that answer is yes. So again, we're doing u minus v. And it's easier because they both start here. So I know this vector is going to be whatever that endpoint is. And that is going to be at 8, 6. and v equals, looks like it's 7, negative 4. Okay. So the first thing we need to do is graph our second vector as a negative. So our second vector, it's u minus v, so this is our second vector. So then we go negative v. Okay. Then we draw our negative u, or not a negative u, we draw u over here on this side. And we also draw our negative v on this side. So this is our negative v, this is u. Now we go back to our initial point and draw a vector from where everything began, and it goes to where those two vectors meet up there at the top. Okay, see that negative v, and here's u, and we're going to draw from our initial point all the way up to where those two arrows meet right there. So then we say, what is that point right there? Okay, u minus v is going to be at 1, comma, 10. So again, if I went 8 minus 7, I get 1. 6 minus a negative 4, I get 10. So that's a way to check ourselves and make sure it's the same, it's correct. All right. Now, to find the magnitude of that, we say our magnitude again, you write it like this. Magnitude equals 1 squared plus 10 squared, and this would have to be squared. So this again goes back to a squared plus b squared equals c squared. And I'm going to say 1 squared plus 10 squared equals our c squared. Okay. And then we say 100 plus 1 is 101 equals c squared. This is where a lot of students forget. Make sure you take the square root. So c equals, oh, does 101 break down? I'm almost thinking it's prime. 2 doesn't go into it, 3 doesn't go into it, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't. Yeah, so I'm pretty sure it's going to be prime. So I say that's approximately 10.05. Oh, I forgot the squiggly lines. So the magnitude of u minus v is approximately equal to 10.05. Okay, sorry this was a little lengthy, students, but you can get this. You rock.